Hello guys, in our class today we'll be talking about sets. Sets. So we're going to be looking at sets and then set notations. So first, when we talk about sets like this is actually one of my favorite topic in mathematics, sets. Now what is set? Set is a group of well-defined objects or things. A group of well-defined objects or things. This is called what? A set. For instance, you can say um, list all the numbers or list all the prime numbers less than 10. List all the prime number less than 10. I can say that set A contains the list of prime numbers less than 10. Such is the set, a well-defined. So I know exactly what I'm looking for. So for instance, I'm saying, okay now, for instance, P is a set. A set starts at prime numbers less than 10. Prime numbers less than 10. So we'll say prime number less than 10. There are this P. Remember, in under set, we use capital letters like this to represent or to name our set. You don't use small letter. And another thing again is that when you want to list all your set, we don't just use curve like this. No. We use this. Look at it. Can you see that? It's like kind of like a steric, you can say a coily one. So this is exactly what we use. Okay, we use that. So please don't forget. It's very important. We use capital letter to name our sets, and then when we want to list all the sets, we don't just use close bracket like this. No, we use something like, see, it's coily. Coil. That is exactly what you use to to list out all the elements of the set. So for instance, this set you are having a set list of prime number less than 10. So it's a definite, it's a well-defined. So we know exactly what we are looking for. So now this this prime number less than 10. Remember what is a prime number? Prime numbers are numbers that has only two factors, which are 1 and itself. So that's a less than 10. Less than 10. So is 1 a prime number? Remember, 1 is not a prime number, so 1 will not be there. So the first prime number that comes to our mind is what? Is 2. The next one is 3, 5, 7. Yeah, I think these are just the only prime numbers less than 10. So this is a set. So set P now is what? A group of prime number less than 10. So that is it. So whenever you hear the word set, it's not difficult. Remember, set is just a group of well-defined objects or things, just like what we have mentioned here. And remember again that we use a capital letter to name our set. And then when you are listing the element in a set, don't forget you must use comma like this. And then instead of using just bracket, our bracket must be what? A coily one like this. So that is the basis. That is the foundation of set. So once you know this, you are now in the process to dig deep into set. Now, in other set, what are some other things that we need to also take note of? Like all this you are seeing, what are they called? They are called the elements. They are called elements of this set. They are called elements of this set. So if you look at 2, 3, 5, 7, they are the elements of what? Of set P. So what are elements? Elements are what? Are what is contained in a set. The elements are what is contained in a set. So like in this set, now the element of set P, they are what? 2, 3, 5, and so that is the element of set P. So for instance, now I can say that 2 is an element of P. Now if I want to write 2 is an element of P, how do I write that in set? I can say, write that like this, that 2 is an element of what? Of P. That is it. This means 2 is an element of P. That means that 2, you can find 2 among the what is contained in this set P. Now, how will I say? Look at something else again. If I want to refer to 8, what will I say? Can I say 8 is element of P? Is it possible? Look at this. We have 2, 3, 5, and 7. Can you say that 8 is an element of P? What do you say? Okay, you answer right. 8 is not an element of what? It's not an element of P. So how do you write that in set? How do you write that 8 is not an element of what? of P. So you do this. Look at this. This sign means what? Not element. That means not included. It's not a member of this set. Okay, so this means member or element. This means not element. So please take note of these. They are what? They are set notations. They are set notations. Element, not element. Now, having mentioned what sets are, and then some of the notation, now it's very important also for us to also think of another thing again. Now, using this very particular set I'm having here, there's another question I can ask. What are the numbers of what? Of set P? What are the number of elements in set P? How do I write that? I can easily write that. That will not be what? N, but you see N this. So element, that means number of what? Element in set P. That is what this means. And so using the same example, the number of elements in set P, how many are they? They are what? 1, 2, 3, 4. So it is just what? 4. However, take note of this. When you are listening at the numbers of elements in a particular set, if for instance there is a repetition, for instance I have a set like this Q. I have 2, 2, let's say 3, 4, 4, 5, 5, 5, 6, 7. Now look at set Q. What is the number of elements in set Q here? What is the number of elements in set Q? I'm not listing sets, so I don't need to write that. So the question is, what is the number of elements in set Q? Will you say the number that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Will you say 10? You can say 10. Why? Because if you look at this, 2 is repeated twice here, 4 repeated twice, 5 3 times. So if you want to know the number of elements in this set, we'll take only 1. This is what? 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, 6. So the number of elements in set Q, they are just what? Is just 6. So that is it. Not difficult at all. 6. So remember, when writing out the number of elements, when you have number, the repeated number, like just take only one of them. Now, under set notation again, there are other things we need to know again. Sometimes we talk about a subset. Yes, a subset. How do you write that? We'll say subset. What do we mean? For instance, now, okay, I have a set like this. Let's say, okay, let me use Y now. Y. Let's say Y contain all the integers less than let's say less than 15, less than equals to 15, integer less than equals to 15. So if you want to write that, I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This was integer. That means Y less than equals to what? 15. Okay, so of integers. Now I have a set like this. This is called like the universal set. Okay, so like the universal, because in other sets you keep on hearing a word like that, you definitely hear universal set. So when you hear universal set, from the name, what does that cause to mind? Universal, all inclusive. It's like the warehouse of what? Of the set. Okay, so the universal set is what? It contains all the other sets. Whatever set you want to call, you'll find them in the universal set. Okay, now for instance, I have a universal set like this, and then maybe I now have another set, like let me say K now. K, let me say K is 2, 6, 8, 10, 12, and 14. And then I have let me use another one now. Is it M? I have, let me say 1, 3, 5, 7, 9, 11. Good. If you look at set K and set M, you find out that all the elements that both of them contain, you can find them in this set Y. All the elements that you can find in set K and in set M, you can find everything in set Y. Meaning that set Y is a universal set. Universal set because it has all the set that is included in other set that is under it. Okay, now another way again we can do something else again that comes to mind is now what? A subset. We can also say that what? That K is a subset of Y. K is a subset of Y. Now, how do you write that? You say K is what? Is a subset of Y. Meaning that what? All the elements in K can be found in Y. That is meaning of subset. Subset is a subordinate. Yes. K is loyal to Y. You know why? Because everything that K has got it from K, got it from Y. And the same thing also can be said of M, that M is what? Is a subset of also what? Of also Y. Now, under set notation, there's something else again we need to know. I can easily tell the number of subsets in any set. The number of subsets in any set. Okay, like for instance, in this particular set now, let me say this now. Let's use for instance, let's go back to this set P now. This set P I have here, I can easily tell the number of what subset that is in this set. The number of subsets in this set of P. How will I know that? I can easily do something like this by listing all the sets out. Okay? Or let's take another example again now. If I want to say, let me use another one again. Let me say Q. Oh, I've already used Q. So this time I'm going to look for, let me use another, let me say N. Set N now. Say set of, let's say set of even number less than 8 or less than 10. So even number less than 10, we have 2, 4, 6, yes. Less than 10. Now, what is the subset of this? If you are asked, list out all the subsets of set N. List out all the subsets of set N. How do we do that? And do this. 2, 4, 6. We have 2, 4, 2, 6. We have 4, 6. Then we have the set itself, because every set is a subset of itself. So 2, 4, 6. And then an empty set is always a subset of every set too. So how many do you have? You have 1, 2, 3, 4, 5, 6, 7, 8. Yes. So we have 8 subsets. So set N has what? 8 subsets. Now, if I don't want to mention, if I want to write out all this, for instance, I have a set like this now. Now, the question says, what is the number of subsets that is contained in set Y? Will I now start to list them like this? What is the formula? There's a formula we use in getting that. So the formula will now be what? Will be what? 2. So the subset now, subset of N now, will be what? 2 raised to the power of what? N. This N stands for the number of what? Terms you have in there. So the formula you can use to get all the subset of any set is what? 2 raised to the power of what? Of N. For instance, if I want to know the number of subsets in this set N is equals to what? 2 raised to the power of what? Of N. What is N there? N means the number of what? Elements in that set. And that is what? 1, 2, 3. So this is equals to what? 2 raised to the power of 3. And 2 raised to the power of 3 means 2 times 2 times 2. That is equals to what? 8. And that is what you are seeing here. 1, 2, 3, 4, 5, 6, 7, 8. So if I want to know the number of elements, the number of subsets in this set Y, the same thing. What do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. So that would be what? 2 raised to the power of what? 15. You multiply it, you get your answer. So it's not difficult at all to get the subset or to know the number of subsets in any set that is given to you. So that is all about what? Set notation. And then don't forget your empty set. We talked about what? Element of a set, subset also. So as we go deep into set, you'll be seeing other notations and then how you can answer questions under them. But for you to have a deep understanding about set and set notation, I encourage you to watch this video over and over again so that you understand this concept very well. So by the time we start applying them in answering questions, it won't be difficult for you. Once again, thank you so much for making our time to watch my videos. And if you have not subscribed, I encourage you to please consider subscribe so that when I upload new content, you'll be notified of them. Thank you. Bye-bye.